Hey guys, welcome back. So the objective of the last video was to look at the linear regression. So now the objective of this video, we want to look at the concept of the least square regression line. Okay, so least squares regression line. So we discussed this during the last part of the last video, right? So we have a linear relationship of y bar of a times x plus b. So ALS, the LS here, basically means least squares. Okay, so basically this line here represents our line of best fit that will best describe the data. All right, so where the coefficient, okay, a and b, are basically values such that the sum of the square of the residuals of every data point xi, yi, okay, are being minimized. Okay, so these coefficients here are being restricted in such a way that the sum of the squares of the residual are being minimized. So I won't go through the derivation, but it turns out that the coefficients for the least squares regression line, or in other words, the coefficient of our line of best fit, is equal to this. Okay, so before b, BOS is equal to sxy over sxx. Okay, with sxy equal to this, right? Okay, of the sum of xi, yi minus 1 and n, sum of the product of sum xi times sum of yi. Okay, and sxx equal to the sum of the xi squared minus 1 and n, okay, times the sum of xi entire thing squared. Okay, so normally we're given a set of data. So back to our example here of the money you receive in each year, right? We're given a set of data of xi, so 1, 2, 3, 4, okay, and yi, 850, 798. So when you're given this data, you can just basically sub that into this formula here, right? These formulas here, and you can get straight away and get your coefficient BOS, okay, and sub into here. So now let's find our ALS, okay, and so ALS turns out to be y bar minus BLS, which is found here, times x bar. So y bar is the average of all the yi's, and x bar is the average of all the xi's, okay, so which is said here. So y bar is the average, y bar is the average of all the yi's here, okay, x bar being the average of all the xi's. Okay, so once you find all of that, you sub that into this equation here to find your A coefficient, ALS, and then you sub back into here to find the least squares regression line, okay, which will be our line of best fit that will best describe our data. So, another terminology is another terminology that we're going to introduce is called the correlation coefficient of two variables xi, yi. Okay, so again, we are again given two sets of data of x and y's. Okay, so our correlation coefficient, which we denote as R, is equal to this. Okay, sxy over square root of sxx times syy. Okay, and this is what syy and sxx and sxy is equal to. Okay, so this is the correlation coefficient formula. Okay, and most questions would ask about this. Okay, so the next video we're gonna give an example of how we can use these formulas, okay, of the coefficient of A and B and also now R. Okay, see you guys in the next video.